Section, we are going to be multiplying polynomials and using FOIL. First of all, what is a polynomial? Well, if you go to the book, it reads, a polynomial is the sum of one or more monomials. Well, what's a monomial? A monomial is a number, a variable, or a product of variables raised to powers of positive whole numbers. So the exponents cannot be negative, and they cannot be fractions or decimals. So that is the definition of a monomial. Examples of monomials, like for instance 3x squared. The exponent is positive, and it's a product of a number and a variable. Here's a few more. You could just have a number, you could just have a variable, or you can have a combination of all three as long as all your exponents are not negative and not decimals. A binomial, on the other hand, has two terms. A term is separated by a plus or a minus. So here is two examples of binomials. What about trinomials? A trinomial, like the term says, tri, has three terms. So here's two examples of trinomials, and again, notice how the exponents are not negative and they're not negative fractions or decimals. So in this section, that's what we're going to do. We're going to multiply all of these monomial, binomials, and trinomials together. So let's go ahead and do that. So let's start with a monomial times a binomial. What you do is just use the distributive property. So you take the outside term, the monomial, and you multiply it by each term in the binomial to get 6x squared, because 2x times 3x is 6x squared, plus, you always have to put a plus, and then 2x times 5 is 10x. Give it a little harder example, doing the same thing, using the distributive property. Take this monomial, multiply it by the binomial. You would get negative 3x squared times negative 4x cubed, which is 3 times 4 is 12x, and we learned that we add the exponents in the first chapter, so that would be 12x to the fifth. Then we always put a plus or a minus, but since the negative 3 times positive 7 is negative, so I might as well just write a minus there, and it would be 21x to the third, because adding a negative 21x is the same as minus 21x to the third. Said the 3 wrong, but other than that. Now let's give an easy example of a binomial times a binomial. That you would just use the distributive property twice. So we would take the x and we would multiply it by both terms. Give us an x times an x, which is an x squared, and then x times a 4, which is plus 4x. Then you do the same thing with the 3, putting a plus sign in between each, because they're each different terms. You get a 3x for the 3 times the x, the first one, and then finally the 3 times the 4, which is 12. And they usually notice that you can combine like terms. X squared plus 4x are not like. To be like terms, the variable part has to be exactly the same. You saw in the last section. But 4x plus 3x are like terms, so they would usually simplify this by writing a 7x here. And this is where FOIL comes in. FOIL is an easy way to remember what you have multiplied when you multiply a binomial times a binomial. What does FOIL stand for? F stands for first, O stands for outer, I stands for inner, and L stands for last. And if you notice, that's what we did here. The first was the x times the x on each binomial. The x's were the first, making it x squared. The outer was the two outer terms you could see as 4x. Then the two inner terms is 3x. And finally, the last of each binomial was the 3 and the 4, which made the 12. So let's do this with a harder example. So if you think of the first, you have the 2x with the 3x, the first of each binomial, giving you a 6x squared. Then you always put a plus or a minus in between. I'll just put little pluses there to remind ourselves. So we're going to add the next term, which is the outer, which is the 3x with the 7, giving 21x. And then the inner, which is plus negative 5 times 2 is a negative 10x. So you might as well just write it as minus 10x, because subtracting a 10x is the same thing as adding a negative 10x. And then finally, the same thing. We have the last, and that would be a minus 35 or plus negative 35. Again, we can add like terms. The two middle terms are like. So that would be 21x minus 10x is 11x. The answer to our fourth example. Our last example is a binomial times a trinomial. You have to be very careful because FOIL does not work here. FOIL only works for a binomial times a binomial. There's too many terms. So we're going to go back to just using the distributive property twice. Once for the x and the other for the negative 5. So let's do it for the x. So the first term would be x times x squared, which is x cubed. And then the x with the next one, that would be a 3x squared plus 3x squared. Again, we have to add or subtract because these are going to be different terms. Just moving it down a little. And then we would have the last term, the negative 2 with the x, giving us a minus 2x squared or plus, minus 2x or plus negative 2x. Doing the same thing with the negative 5. So the first term with the negative 5 is a negative 5x squared. Then the negative 5 with the middle term, which is minus 15x. And finally the negative 5 with the negative 2, because you have to think this is a plus negative 5 with a plus negative 2, which gives a positive 10, by the way. Now, again, they do simplify, so you have to look for all the like terms, since we have 3x squared and a negative 5x squared added together, which is what you learned in the last section. That would be minus 2x squared. And then you can have a 2x, negative 2x, added to a negative 15x, which is a negative 17x. And finally, let's just add that 10, and that would be the answer. Notice how we have the first, actually I should have said, is too many for FOIL, right? There's 6 terms that we had before we added them together. That is how you multiply a binomial times a trinomial. And then anything harder, trinomial times a trinomial, you do the same thing. You take the first term times all 3, the second one times all 3, the third times all 3. But this is about as hard as you're going to have to do in this class.